Welcome to Btechnical. This lecture I have started in view of Bpsc AE advertisement number 29 2025. So this is continuation of Geotechnical Engineering revision lecture. This is fourth lecture. Uh, last three lectures already uploaded in the channel. You can go and visit. So let us start. Now the next term is consolidation and compaction. As you know, consolidation and compaction. Consolidation is the methods of decreasing the volume. Means as you increase the load, there is an expulsion of water from the soil. That is called consolidation. Consolidation means water is squeezed out from the soil. Whereas compaction is as we increase the load, the expulsion of air from the voids of the soil. That process is called as compaction. So in compaction also we reduce the volume, and in consolidation also we reduce the volume. This is the main difference of consolidation and compaction. So we can say compaction is an instantaneous process and consolidation is a time dependent process, since the water is squeezed out from the pores of the soils, right? So it is time dependent phenomenon, whereas compaction is a instantaneous phenomenon. And in consolidation soil is fully saturated, whereas in compaction it is partially saturated. So these are the key difference of this consolidation and compaction. So let us come to the point. So compaction can be done by a test called as Proctor test. Proctor test. In 1933, a scientist was Proctor who given this test to measure the compaction. So there are two Proctor tests. One is called as standard Proctor test and other is called as modified Proctor test. There is slight variation. In standard there is 3 layers, 25 number of blows, height is less, but in modified the height is more, weight of hammer is more. In standard weight of hammer is less, and in modified there is a 5 layer, in standard Proctor 3 layer. So these are the difference between standard and modified Proctor test. And when you there is some questions on objective, what is the energy in modified Proctor test. So it will come to 4.5. when you calculate from this data, you will get the 4.5 is the energy. So as you see, here is the graph. This is dry density and water content. So compaction, draw a curve between dry density and water content. So as you increase the compaction energy, from here to here, this curve is for standard Proctor test and this curve is for modified Proctor test. So as we increase the impact energy, compaction energy, the curve is shifted towards left. Okay, so that means dry density will increase. You can see here dry density will increase, at the same time optimum moisture content is decrease. Okay, here is the optimum moisture content is more, here is the optimum moisture content is less. So as you go from standard to modified Proctor test, the optimum moisture content will reduce, at the same time dry density will increase. Dry density of the soil will increase, mean it will get more compact. Okay. This is the Proctor test. IS code also classify the light compact test and heavy compact test. Here is also the same difference. There is in light compact test the weight of hammer is 2.9 like that, and in heavy compact 4.6, means weight of hammer is increased, height of fall is increased in heavy compaction, number of layer is increased like that. Okay, so this is for compaction. Now come to consolidation. Terzaghi give one dimensional consolidation equation. This is many times asked directly in the objective exam. There is a relation which is given by the Terzaghis. Del u by del t is equal to Cv del square u by del z square, where Cv is the coefficient of consolidation, and coefficient of consolidation can be found Taylor's square root fitting method and Casagrande logarithmic time fitting method. Sometimes in objectives these are directly asked, this relationship directly asked in the exam. There is also asked in the exam that square root fitting method is given by whom? That is by Taylor, whereas logarithmic time fitting method is given by Casagrande, and curve is also given. This is square root fitting, this is logarithmic time fitting. Okay, so these are the key points you need to remember in the mind, you kept in the mind at the time of examination. So Taylor given Cv is equal to 0.848 d square by t, whereas the logarithmic time fitting method which is given by Casagrande, that is Cv is equal to 0.196 d square by t. Okay, where d square, d and t are as usual meaning in now there is some settlement due to this consolidation. There is so many types of settlement: immediate settlement, permanent settlement, like that. So immediate or initial settlement sometimes asked in the exam, that is SI, denoted by SI. SI is equal to Q times B into 1 minus mu square divided by ES into IT, where IT is the influence factor. IT is the influence factor. Q is the intensity of contact period, means contact with the soil, and ES is the modulus of elasticity. ES is the modulus of elasticity of the soil. Mu is the Poisson's ratio, and B is the width of the footing. If you want to the immediate settlement in the footing, then B is the width of the footing. Okay, so from this formula you can find out the immediate settlement. Next is the primary consolidation settlement. Primary consolidation settlement when there is different parameter which are given in the question. So based on void ratio, if void ratio, that is E, is known, then the formula is delta H is equal to H naught into del E by 1 plus E naught, or you can also say delta H by H is equal to del E by 1 plus E naught, where del E is the change in the void ratio from initial to final, and 1 plus E naught. E naught is the initial void ratio. Initial void ratio. Okay. Next is when volume of compressibility is given, MB. When MB is given, then again del H upon H naught is equal to MV into del sigma bar. Okay, and from that you can find out the settlement delta H equal to H naught MV into del sigma bar. Del sigma is the change in stress, change in pressure. Then coefficient of compression is known. When coefficient of compression, that is Cc, is known, we see the expression for Cc, how to Cc is determined. Then there is also some expression for to find the Cc. So when Cc is given, that is coefficient of compression is given, at that time delta H is equal to Hc H naught, that is initial height of the soil, into Cc divided by 1 plus E naught log base 10 sigma naught bar plus del sigma bar divided by sigma naught bar. So this expression used for the settlement, consolidation settlement, when Cc is given. Similarly, when coefficient of recompression is also given, then the total settlement will be due to the coefficient of compression and coefficient of recompression. So delta H is equal to first due to coefficient of compression and coefficient of coefficient of recompression, coefficient of compression. So delta H equal to H naught Cr. Just this value will change. The expression is as in the earlier one. So when you use this recompression, then initial state sigma naught to sigma 1 changes, and in case of Cc there is sigma 1 to sigma 2. So this expression you have to use when coefficient of recompression is given, and you apply the coefficient of recompression. Yeah, you taken this effect of this recompression, right? Next is coefficient of compressibility, AV. AV is equal to the ratio of change in void ratio to the change in stress. Change in void ratio to the change in stress. So void ratio is unitless quantity, so its unit is the stress. So stress is in denominator, so it is meter square per kilonewton instead of kilometer per meter square. It goes to up, so meter square per kilonewton. Sometimes this expression is also asked in the objective examination. Okay, and we just rewrite this equation. Del E means E naught minus E1, and del sigma bar means sigma naught bar minus sigma 1 bar, means initial minus final. Next is coefficient of compression, Cc. So again Cc is the there is nothing difference between AV and Cc, only the difference is it is taken on logarithmic scale, right? So again change in void ratio divided by change in stress in logarithmic scale, right? So this is the expression for coefficient of compression, that is Cc, as you talk here is the Cc. And there is so many empirical relations to find this Cc, this coefficient of compression. Cc is equal to when WL is given, means liquid limit is given. WL is the liquid limit. When liquid limit is given, at that time Cc is equal to 0.009 into WL minus 10. When this expression is used when the clay is undisturbed clay, right? For remolded clay, the expression will change. Instead of 0.009, it is 0.007 for remolded state. This is remains same, WL minus 10, where WL is the liquid limit. And third one is for organic clay, Cc is directly equal to 0.015 into Wn. Wn is the natural water content. So this expression is used to find the Cc. Now coefficient of recompression, again here only this logarithmic scale is taken. So change in void ratio divided by change in stress in logarithmic scale, right? So you can say this Cr value is 1/5 to 1/10 of Cc. So if you know the Cc, then Cr is equal to, you can taken 1/5 to 1/10 values, okay, directly. So this is asked in the objective exam many times. Now again you can find out here the important relation, del V upon V naught is equal to del H upon H naught, means change in, again you can find out here the settlement, delta H is equal to H naught into del V by V naught, or you can write this expression as delta H is equal to H naught times del V upon V naught, or del E upon 1 plus E naught into H naught. Okay. So from this expression, if anything is any two things are given, you can find the settlement. Similarly, coefficient of Cv is equal to K upon Mv into gamma W. If you remember, when we discuss the permeability relation, permeability chapter, at that time this relation is was come, right? Means K is equal to Cv Mv gamma W. From this relation you can find the permeability. Again, if permeability is given, Mv is known, gamma W is known, you can find out this Cv. Okay. So this is also rewrite like that. mv is the, here mv is the coefficient of volume compressibility. So mv is equal to av upon 1 plus E naught, and you can rewrite this term del E upon del sigma bar. Why? Because of this AV. AV is the, we already discussed AV here. AV is the coefficient of compressibility. Coefficient of compressibility, that is nothing but ratio of this change in void ratio to the change in stress. So just we rewrite here del E upon del sigma bar is the, this is the AV, right? Again you can write del E upon del sigma. So del E upon del E divided by 1 plus E naught. So del E upon 1 plus E naught, this is nothing but del V upon V naught. So just write del V upon V naught here, and you can say, so final expression mv is equal to del V upon V naught into 1 plus del sigma bar. Okay. Now come to the next. One important term is time factor, TV. There is so many small numerical question for 1 or 2 minutes on this time factor, that is a degree of, TV is the degree of consolidation. So TV is equal to CV T upon D square. Again CV you know, already discussed earlier, and T is the time for time of the consolidation, time factor. Then D is the length of drainage path, So if double drainage is there, then you directly take whatever be the thickness of the clay, that divided by 2 for dry drainage, means D is equal to H by 2 for double drainage, and D is equal to H for single drainage, right? And TV you can directly find this expression, TV is equal to pi by 4 into U by 100 ka whole square, where U is in percentage, right? So if it is less than 60, means degree of consolidation, if less than 60, then you use directly this equation, and if it is greater than 60, then there is a different expression. So here is the standard value are given, you have to remember for the objective questions these values. TV, degree of consolidation for 50 degree consolidation, this value is 0.196, and for 90 degree consolidation, this value is 0.848. You can directly remember this formula for objective, and also use for to solve the numerical questions, right? Next is the seepage discharge. What is seepage discharge? The expression for seepage discharge is QS is equal to KH into NF upon ND, where NF upon ND is the safe factor, K is the permeability, H is the head, right? Next is the principal stress. As you know, the principal stress sigma n from the strength of material point. We know the what is principal stress. Principal stress is where shear stress is 0. So sigma n is equal to sigma 1 plus sigma 3 divided by 2 plus sigma 1 minus sigma 3 divided by 2 into cos 2 theta. Okay. Sigma 1 and sigma 3 is the stresses, right? Sigma 3 is the cell stress. Similarly, shear stress you can find that sigma 1 minus sigma 3 divided by 2 into sin 2 theta. For shear, sin is here, for sigma n, cos theta is here. So if you know the sigma n and tau n, you can find the resultant stress, that nothing but the root over the sigma n square plus tau square. This is the failure strength, shear strength, that is S is equal to sigma n tan phi when C is equal to 0. Okay, when C is equal to 0. If C is there, then S is equal to C plus sigma n tan phi. So C is 0 for which soil? Cohesion-less soil. Cohesion-less soil. For cohesion-less soil, value of this C is equal to cohesion is 0. Next is sigma 1 is equal to sigma 3. This is expression for sigma 1. To find the sigma 1, sigma 1 is equal to sigma 3 tan square 45 plus 5 by 2 and plus 2c tan 45 plus 5 by 2, where c is the cohesion, sigma 3 is the cell pressure, phi is the coefficient of friction of the soil. Okay, so this term, yani tan square plus tan square 45 plus 5 by 2 is nothing but n phi. and if it is 10 45 plus 5 by 2, then you can write directly by root under n5. Just square term is omitted. Okay, so this expression used for to solve the numerical question. Okay, next is the maximum angle of obliquity. You can directly find the maximum angle of obliquity, that is beta is equal to tan inverse tau upon n, where tau is the shear strength. I already discussed here the expression, and sigma n is the normal stress, shear stress and normal stress. So maximum angle of obliquity is find from this formula. Theta c is 45 plus 5 by 2. This is critical angle. Next is the deviator stress. You know the sigma 1 minus sigma 3, the difference of sigma 1, the principal stress, minus cell pressure stress is nothing but deviator stress. Next is sin phi dash, means when these two values are given, sigma 1 and sigma 3, you can find this phi value. The relationship is nothing but sigma 1 minus sigma 2 divided by sigma 1 plus sigma 3. And another question is when this phi value is given, you can find out this sigma 1 and sigma 3. Next is unconfined compression test. Unconfined compression strength is Qu is equal to P upon AF, where AF is the area of failure surface. Okay, and once you know the Qu, then you can find the cohesion value. Cohesion value for unconfined compressive strength is Qu by 2. This is many times asked in the objective exam. So many exams, there is one numerical question for this unconfined compressive strength test, right? So this is nothing but C is equal to Qu by 2. If you know the value of Qu, you can directly find C. If you don't know Qu is equal to P upon AF. At that time P is given, and AF you can find out by this expression, area of failure. AF is equal to A naught upon 1 minus EL. So A naught is the initial area, initial cross sectional area, right? And EL is the this is not EL, this is epsilon L. This is nothing but the strain, longitudinal strain. Okay, so this expression is used when volumetric strain is 0. If volumetric strain is given, then you can find this by this expression. AF is equal to A naught 1 minus epsilon V divided by 1 minus epsilon L. Okay, so if you volume epsilon V is equal to 0, then this is same as above, AF, A naught upon 1 minus EL. Next is Scampton equation. Scampton equation is there is so many 2 parameters in the Scampton, that is B and A. So you can find this B Scampton parameter, that is nothing but B is equal to the ratio of consolidated change in pore water pressure in consolidated state to the change in stress in consolidated stage, right? And A bar is the drained stage. Okay, this is consolidated or this is drained. So A bar is the del UD by del sigma D, and this A is equal to A bar upon B. So this expression directly asked in the exam. Expression itself asked in the exam by directly. When you put this in this equation, means you can directly find from here del UC is equal to B into del sigma 3 plus A del sigma 1 minus del sigma 3. This is nothing but deviator stage. You can find here this is del sigma D. Okay, and now we just multiply this B value, B into del sigma 3 into B into A, and A is nothing but A bar by B, so B cancelled out. This is A bar into del sigma D. Now A and B is the Scampton pore pressure parameters, where B is Scampton pore pressure parameter. There is some relation, some values on which objective questions may ask in the exam. Means when soil is fully saturated, at that time the value of B is equal to 1. When it is partially saturated, the value lies between 0 to 1. It means that for dry soil, this value of B is equal to 0. So you have to remember this for objective exam. For Bpsc point of view, there is previous year you can find directly the question. For fully saturated, what is the value of for Schedule 4 pressure parameter, that is equal to 1. Now when shear test, this is also a soil test from which you can find the strength of the soil, that is S is equal to T upon pi d square h by 2 plus d by 8. Same is S is equal to T upon pi d square h by 2 plus d by 12 when it is one way shear. There is two types of shear in the when shear test. So if two way shear means top and bottom both are constant. One way shear is only bottom is constant, top is fixed. Either top is fixed, either bottom is fixed. So one way shear, this expression is only this value is has changed. Means instead of 6 it is 12, but in two ways here it is d by 6. Remaining things are remain same. So from this expression you can find this torsion value. So T is equal to S. If S is given, this all things are given, then you easily find out this torsion. Now come to earth pressure. One thing I forgot to told you, that this test is used for cohesive soil, that is soft to medium clay. Cohesive soil means clay. Soft to medium clay. This when shear test is used. Now come to earth pressure. So in earth pressure means as we know, the retaining wall, concept of retaining wall, cantilever retaining wall and gravity retaining wall. Okay, so these retaining walls are due to this come in the picture. Design of retaining wall come to retain the soil, and the soil is retain the soil means the earth pressure come on this retaining wall. Okay, so how this earth pressure is generated? So there is three condition in the earth pressure test. Means when suppose this is soil, so if it is filled, means in which side, means if soil is filled in this side, then this soil is retained by this wall, that is called a retaining wall. This wall is called as retaining wall, and this soil is retained by this soil. So when soil is in this side, so this portion is called as hill, and this portion is called as toe. This portion is called as hill, and this portion is called as toe. Okay, where the material is filled, that portion is hill. Opposite is the toe. So there is so many things when we discuss on RCC and design of RCC structure, then we told you in detail what is the stability condition of this retaining wall. First you see here what is earth pressure. So this soil exert pressure on this wall, that is called as earth pressure. So when soil is in rest, the earth pressure is called as rest. At that time the coefficient of earth pressure K0 is equal to mu divided by 1 minus mu. Mu is the coefficient of soil, Poisson ratio of the soil, right? So when it is at rest, mu upon 1 minus mu. So you can directly find the pressure due to this earth at rest. Then P0 is equal to 1 by 2 Ka gamma into S, because pressure is like this triangular in shape. Okay, like this. So here is the pressure is gamma H. So you need to write the area of this triangle. So 1 by 2 base into this height is H. So you can multiply directly to find the P0 value. P0 is 1 by 2 K0 gamma into H square. Similar way, when it is active, when soil is active, means the wall is away from the soil. At that case, this is called as active soil. So in this case, the value of coefficient of earth pressure Ka is equal to 1 minus sine phi upon 1 plus sine phi. Phi is the soil friction angle. So if phi is given, means basically it is 28 to 34 degrees. 34 degree. So 1 minus sine phi, 1 plus sine phi. From here you can find out this Ka, coefficient of active earth pressure, and pressure is in the same way 1 by 2 Ka gamma L square. If the soil is towards the earth means when wall is pushing the soil, at that case it is passive. Okay, so at that time the coefficient of passive earth pressure is Kp 1 plus sin phi upon 1 minus sin phi. This is nothing but Kp is inversely proportional to Ka. So from this expression, sometime in exam, the numerical question may directly ask on this expression. Earth pressure is at rest, active and passive. Now come to this point. When this soil is backfill in inclined position, right, some angle of beta, suppose. If it is horizontal, then you can directly use this expression. But if this soil is inclined position, the surface is not horizontal, it is inclined at an angle of beta, at that time the coefficient of earth pressure is slightly change the expression. That K is equal to cos beta minus root under cos square beta minus cos square phi divided by cos beta plus root under cos square beta minus cos square phi, where if you put the if you put beta is equal to 0, means this is not in inclined position, it is horizontal position, then beta is equal to 0. So put beta is equal to 0 in expression, you will get this expression 1 plus Ka, this expression 1 minus sin phi by 1 plus sin phi and 1 divided by 1 plus sin phi, this expression, and reverse of inverse of this expression you can find Kp, this expression, right. So Ka into Kp is nothing but cos square beta. So this is also directly asked in the objective. Now come to the next point, earth pressure for cohesive soil. For cohesive soil, there is coefficient of cohesion come to the picture. Then sigma u is nothing but sigma v into Ka minus 2c into root under Ka. And for this is for active earth pressure, and for passive earth pressure, this minus change to plus, means sigma v into Kp, here instead of Ka it is Kp plus 2c root under Ka. Okay, now unsupported vertical cut in the cohesive soil. Cohesive soil, there is some unsupported vertical cut, that is suppose the center is z, so total is total is 2z, 2 times into z, meaning hc is equal to 2 into z. hc is the total vertical cut. So at that time hc is equal to 2z, so 2 into 2c by gamma 1045 plus 5 by 2. This is nothing but n phi, if you remember the class as discussed in above. So this is nothing but root under 10 phi, not n phi, root under n phi. So you can directly 2 into 2c divided by gamma, that is 4c by gamma into root under n phi, or 1045 plus 5 by 2. Okay. So next is the specific yield and specific retention. Specific yield is volume of water yield divided by total volume, means yield from the void of the soil. So how much volume of water yielded from the voids divided by the total volume of the soil, that is nothing but specific retention, Vwy upon V. And specific yield, specific retention is volume of water retained in the void, volume of water retained in the soil against the total volume. So this is Vw, you can write here R, Vwr by V. Okay, so this is specific yield and specific retention. If you add both specific yield and specific retention, then Vwy plus Vwr, you can write here, that is nothing but the volume of void divided by total volume, that is porosity. So volume of specific retention, specific yield plus specific retention is equal to porosity. So this expression is also asked in the exam, you need to remember. Okay, one more thing I want to discuss, that is, suppose this is a wall, okay, and soil is fill here. Okay. So in case of active and in case of passive, suppose I draw here another, this is a wall and soil is fill here. Okay. So in case of active earth pressure means wall is away from soil, wall is towards this side. Okay, in case of active, this is active, this is passive. here wall pushes the soil, here wall is away from the soil. This is the soil, this is soil, this is soil. So in this case wall is moving away, so soil is segregated here, means the soil is moved here, so friction generated like this, friction is generated like this. Okay, and this value is 45 plus 5 by 2, 45 plus 5 by 2. This is also asked in many times. And in this case soil is, this wall is towards the soil, means this pushes the soil. Okay, so soil is pushes towards right side, it means the friction is generated in this direction. So in that case this is 45 minus 5 by 2, 45 minus 5 by 2. So this you need to remember. So I stop here. Lecture 4 will come in next lecture soon. Okay, till then, bye bye.